So you better listen.
Is the booster pump back on?
Supposedly, we're gonna find out. I'll show you how to tell.
So, I mean, if they're saying it was on that whole time, what else would cause all the pumps to have like zero pressure when they're running?
One of the makeup valves being off.
Well, plus, wouldn't the discharge in that fucking backflow cause a problem? Because all that water's coming back and going out.
So that's what the backflow is supposed to do, but it's not supposed to fucking
suction
vent.
problem on those pumps?
Yes. Yeah, you can go, bro.
Okay.
We'll be up here for a minute.
All right.
After this, I'll talk to fucking Mike. But with this humidity today, I mean, it was fucking thundering and lightning and dumping in Casa Grande this morning. I thought we were gonna come up here to a mess, but apparently it missed. But there's a fucking ton of humidity in the air, so everything is gonna be fucking super condensating. It's gonna be condensating to the maximum today. So keep an eye out on that. All right. So
Those pumps.
number one, do you guys understand when people say closed loop, open loop? What's the difference between a closed loop and an open loop? I'll tell you.
Closed loop is just recirculating the same water over and over.
Yes and no.
Okay.
So a closed loop is closed to the atmosphere. It's a sealed loop. So if you look at the open loop on the towers, you have water in the basin. It's open to the atmosphere. That's an open loop. All right, so there's two loops on this system. There's a closed loop and there's an open loop. The closed loop goes to all the water source heat pump units. All right, comes back to the, the return water coming back up to the roof goes to these heat exchangers. Let's go over there. So real quick, before we get to the heat exchangers, these are the two main lines of the closed loop going into the building, to the water source heat pumps. You got your supply and your return. What's the temperature? You got to pay attention to that temperature. The supply water should maintain no more than 90 degrees. 90 degrees is it. If we start getting into 94, 95, we run the risk of our unit shutting down on head pressure. So what the heat exchangers do is they cool the water down before it gets pumped back to the units. Okay, so it'll come up here like 110, 120 degrees, hit the heat exchanger, go through the pumps, and comes back at 90 degrees. All right?
These pumps are pushing the supply?
These are the supply. These are the closed loop pumps.
And they're pushing down this way.
Yep.
Sucking back from the heat exchanger.
Yep. You follow the lines. So how do you know which one's the supply line?
One that has no more than 90 degrees. Right?
If everything's working, yes. Right now, nothing's working. So how do you tell what the supply line is? Which way is the water flowing? How can you tell? How do you tell though? If you're looking at this right here, how do you tell which way the water's flowing?
Do these pumps have arrows on them? No?
They do. They 100% do. So that's one way you can tell. On the pump housing, I can't see it, but somewhere on here, is a fucking arrow. There it is. Right there. So your water's going this way. But what about these components? If you're looking at this component and this component, how do you tell which way water's supposed to flow? Where do they always put the regulator on a hydronic system? The actuator. The actuator on the return or the supply? All right. What about this part? Is this a strainer? It is a strainer. So this is your supply water into your pump. That is your actuator, regulator to control your flow. It's also a check valve. So this is a triple duty valve is what they call it. You can adjust your water flow here to whatever pressure you want going downstairs to your system. And then there's a fucking flapper check valve in here. Sometimes these check valves get stuck open. And an indication of that is if you only have one pump running on the VFD command, one pump running, the other pump isn't running, but it's spinning backwards. That's an indication that this fucking check valve is bad. Or not bad, but stuck. And to unstick it, you screw it all the way in and back it all the way back out. Once it's
running,
what's that?
you said you adjust that pressure. What does this run at?
After balance, I expect 40. I expect 40 on the supply side and 60 on the discharge side. All right, so water gets pumped downstairs. Supply water all to all the water source heat pump units. Hot water gets pumped back out. And if you follow the line, never mind this right now, but you follow the line, and it goes to the heat exchanger. Comes out of the heat exchanger. Do you know why it goes in the bottom and out the top? Heat rises, so they want the heat to go in the bottom, and it's cool down and it comes out the top. I guess that doesn't really make sense, huh? But there's a reason why it goes in the bottom.
Same with like a evaporator coil, right?
Correct. That temperature transfer, they're using the laws of physics on top of a mechanical system to cool that water down. So it gets pumped out and goes into the air dirt separator, out of the air dirt separator, into the strainer, into the pumps, through the triple duty valve, down to our water source heat pumps, and then return. And that's the closed loop. All right. So when I say closed loop, I'm talking about these pumps, I'm talking about the heat exchanger, I'm talking about all the lines going down to the water source heat pumps. Now the open loop. Now this system's, the closed loop is closed to the atmosphere, right? So if it was completely full and void of air, there's no reason this should be constantly getting fed makeup water, which is fresh water in, because you're losing water. This system doesn't lose water. So once it's full, there's no air in it, there's no reason why the makeup water should be on. Every time we open the system or make a repair, we introduce air into the system. And it'll probably take a week to work all the air out of it. So we want to try to eliminate leaks. But if we have a leak, we make the repair, we need to know that we need to come up here and fill the system every day for a week, which I believe you've been doing.
I've been doing, yeah.
Okay. So, real quick before we move from the heat exchangers, there's a second side of the heat exchanger. There's the closed loop side, and then there's the open loop side. You got 4 lines coming into it. The in and out are the closed loop on this side, and the in and out is the open loop side of the heat exchanger. All right. Now you'll see the motorized actuators, the orange guys. Those are valves. They're either open or closed. How do you tell if they're open or closed?
They're open.
Orange toggles.
Orange toggles. See how those orange toggles are in line with the pipe? That's telling me that valve is open. See them? Controls these valves. All right, so the valves will do what they need to do according to the programming. You'll also notice this loop right here, this little bypass right there. So this is our closed loop right here, going to our heat exchanger. Then we have this bypass that just bypasses the return water right over to the supply water. That is a seasonal bypass. That opens and closes either in the summer or the winter.
Then it goes to the boilers in the winter, or
No, it just gets, it cuts off, basically it cuts off in the winter. We don't need the heat exchangers. There's enough temperature transfer without the heat exchanger, so that valve will probably be closed in the wintertime.
so what,
There's an actuator valve on top of that bypass.
Open or closed right now?
It's closed. Is this in the opposite direction on the pipe?
I can't tell.
Okay.
It's closed?
Looks like it's
Is it
closed.
closed?
Okay, it's closed.
So do you
So
keep
water
these
is
all
not
open?
flowing through there.
These other hand valves, do you keep those open?
Yep, all the hand valves should be open. The only
Okay.
reason the manual valves are there is to isolate pieces of equipment for either maintenance or repair.
Okay.
And that's, the manual valves are these guys.
what triggers the water to go through these when they're needing heating?
So this is the boiler side of the closed loop. Mike, listen up. This is what the boilers are for. These are gas-fired